Everyone, today we are starting chapter 2. So this is day 1 of unit 2, and we're talking about parallel lines and two lines cut by a transversal. So in my diagram, I have lines A and B and C and D, and then we have this line EF, which is a line that passes through those two lines. So since EF passes through those two lines, EF is considered a transversal. Now we're going to talk about some special angle pairs. We have alternate interior angles. So alternate interior angles are opposite sides of the transversal and inside. So our angle pairs up here that are alternate interior would be angle 3 goes with angle 6, and angle 4 goes with angle 5. Next, we have what are called alternate exterior. So those are opposite sides of the transversal, but they're on the outside of the other two lines. So our angle pairs that are alternate exterior are 1 and 8 and 2 and 7. Now these numbers are just numbered in this diagram. They could always be different. The important part is about where they are in the diagram. Next we have what's called corresponding angles. So corresponding angles are angles that if I were to cut this diagram along this red line and put them on top of each other. So angle 1 would be on top of angle 5. So they are in the same position. So angle 1 is on top of angle 5. Angle 2 is on top of angle 6. Angle 3 goes with 7. And angle 4 goes with 8. Now, the other way you can think about this is if I looked at that top set, what one is in the top left? Well, angle 1. And then if I look at the bottom set, the top left would be angle 5. So 1 and 5 go together. Next, we have what are called same side interior angles. So same side interior angles are on the same side of transversal and inside. So our same side interior angles, if we look, they would be 3 and 5, and then 4 and 6. And then same side exterior are on the same side of the transversal and outside. So these are 1 and 7, and then 2 and 8. And then we have our vertical angles. Vertical angles are always angles that are across from an X. So if we look at the top X, we have 1 and 4, and then 2 and 3. And then we're going to have 5 and 7, or I'm sorry, not 5 and 7, 6 and 7, and 5 and 8. Because 6 and 7 are across, 5 and 8 are across. So those are our pairs. So who cares? Why is this important? Well, these are important because these pairs have a special relation if the lines are parallel. So if AB is parallel to CD, remember my two lines here means parallel. And parallel lines are never going to cross. And cut by a transversal, then my alternate interior angles are congruent. So, for example, a pair of alternate interior angles up here that are congruent if those lines are parallel would be 3 and 6. So 3 is congruent to 6, meaning they're the same measure. Alternate exterior angles are congruent. So in my diagram, that would mean that angle 1 is congruent to angle 8. They're the same measure. Corresponding angles are congruent, so that would mean angle 1 is congruent to angle 5 because those are in the same spot. Then my same side interior angles are supplementary. Remember, supplementary means they had to be 180. So if I said the measure of angle 3 plus the measure of angle 5, those would equal 180. And then same side exterior are also supplementary. So that would be the measure of angle 1 plus the measure of angle 7 equals 180. Now, what type of problem are you going to be asked to do this? If I know in this diagram that AB is parallel to CD, they are cut by the transversal EF. If I know 1 is 115, I can find 3 and 5. So justify and show work. So if I look at my diagram, 1 and 3 make a straight line. They're what we call the linear pair. So angle 1 and angle 3 are a linear pair. That means they add to be 180. So to find the measure of angle 3, I do 180 minus 115, which is 65. Then I know the measure of angle 5 equals 115 because it corresponds to 1. And that's all there is to that problem. So I want you to pause and notice that these ones, they justify your work with the theorem. So that means you're going to tell me what theorem. So number 2 says angle 3 is 2x plus 40, and angle 7 is 3x plus 20. So now we got to think how our 3 and 7 are related. They are corresponding. So our theorem is if parallel lines corresponding angles congruent. So if they're congruent, that means they're equal. So 2x plus 40 equals 3x plus 20. And I solve that. So I subtract 2x. I get 40 equals x plus 20. Subtract 20. And x equals 20. So I want you to pause now. And I want you to figure out 3 and 4. And then come back and we'll go over the answers. Okay, so hopefully you tried these. Number 3, we're talking about angle 4 and angle 5. So angle 4 and angle 5 are what we call alternate interior angles. So my theorem is if parallel lines alternate interior angles are congruent. So I write the equation 4x minus 10 equals 2x plus 20. I solve, I get x equals 15. They then want me to find angle 3. Well, angle 3 and 4 make a linear pair, so they are supplementary. So I find 4 by substituting 15 in. So I do 4 times 15 minus 10, and I find out that 4 is 50. So that means 3 is 180 minus 50, so it's 130. Number 4, we're talking about angle 1 and angle 7. So angle 1 and angle 7 are my same side exterior angles. So my theorem is if parallel lines, same side exterior angles are supplementary. So 2x plus 40 plus 3x equals 180. I solve, I get x equals 28. They want me to find the measure of angle 7. So it's 3 times 28, so it's 84. Number 5, what we need to know here is these little arrows on lines means those lines are parallel. So I want to find the angles. So if these two lines are parallel, this line right here is a transversal. So that means y minus 50 plus y equals 180 because those are same side interior angles. So I solve that equation. So I'm going to add 50 to both sides. Divide by 2. And y equals 115. Now that I know y is 115, I also know that's a quadrilateral. So quadrilaterals have the interior angle sum of 360. So that means if y is 115, that top angle is 115. This one down here is 65 because it's 115 minus 50. This is 90. So that means that 2x plus 115 plus 65 plus 90 is equal to 360. So again, pause and finish that. Okay, so I solved the first one by using same side interior angles or supplementary, and I got y equals 115. I then used the idea of the quadrilateral. However, I really didn't have to. I could have used same side interior again and said 2x plus 90 equals 180. That would have given me the same answer of x equals 45. So now on number 6, again, I want to find the value of x. These lines are parallel. So again, I'm going to use same side interior angles or supplementary. So x plus x minus 26 equals 180. So 2x minus 26 equals 180. 2x equals 206 divided by 2, and x equals 103. And that's it for the video. If you have any questions on anything, please bring them to class.